All right, I've got the answer key to that worksheet. Don't be watching this till you finish that. But no, I just wanted to give you a quick run through of how this was done. Once we have our production function, I made one up that exhibited diminishing marginal returns. You can verify that. Anyway, once we have our fixed costs and our wage rate, the rental cost of capital and our wage rate, we can go from the production function to everything that we want to know about firm costs. Fixed costs are just the fixed costs. Variable costs are the wage rate times whatever quantity of labor we have. Total costs are just the product of the number of, total costs are simply the sum of fixed costs and variable costs. All costs are either fixed or variable. So we add those together to get total cost. To take averages, we're always taking the average of some total cost divided by the quantity of output. So for average fixed costs, it's fixed cost divided by quantity. Average variable cost, it's total variable cost divided by quantity. For average total cost, it's total cost divided by quantity. The marginal cost is a little different. There we're looking at the change in total cost or the change in variable cost. The change is the same. Here the change is always 200, right? We're always adding one more worker. But we divide that change in total costs or change in total variable costs, we divide it by the change in output. And so that 100, 150, 100, that's moving around. So our marginal cost behaves in this manner. It drops initially and then rises. What else to say? Some finer points here. On the graph, notice I've graphed marginal cost at the midpoint between 0 and 100, between 100 and 250. That's the technically correct way, and that's the way to get the marginal cost to actually intersect at the minimum of the average total cost and the minimum of the average variable cost functions, which they must do. When marginal cost, the last one we produced, cost of the last one we produced are below the average costs. That's the average cost of everything we produced. When the last one we produced is cost less than the average, then the average is falling. When the cost of the last one we made is above the average, that average has to be rising. The only way both things could always be true is if those two functions intersect at the minimum. All right. Shutdown price, we just look at where marginal cost and average total cost intersect. I eyeballed that and got 165, but now that I look at it, I see that happens right at quantity 250, which we have a precise number for. It should be 160, not 165. And then the break-even price, you do have to eyeball that. It's somewhere there. What is that? I went to this, the average total cost and marginal cost, and just eyeball where those about equal. Notice that marginal cost is below average total cost here. It's above average total cost here. They intersect somewhere in that range, and I just picked $3.04, the midpoint. Supply curve, remember the supply curve is the marginal cost curve above the break-even price, which is where the where the marginal cost curve intersects with the average variable cost. And then this output choice, that warrants some explanation. If the price is $3.33, how much will be produced? Notice I picked a price that we had a specific point for, but I plotted at the midpoint. If you plotted just at the later of the two quantities, you'd have gotten 490. I got 460. 460 is technically a little better answer, but I wouldn't mark points off for that. So anyway, quantity 460. That's the output, profit maximizing output. And then things got a little too tight in here. I couldn't make it clear that I'm the vertical distance between price and average total cost at 460. That's usually different from the minimum average total cost, but here they happen so close together that you can't really tell. Let me just blow that up to show you what in the typical one would look like. I'm going to go orange just because that's That's what I got going on here. Typically, and this is not to scale in any way, typically we have this average total cost function, and then the marginal cost like that, and then some price, right? Pretend this is like an inset. So the profit maximizing quantity would be there, whatever that would be. And then, this is hard to do with a stylus, but I want to draw my rectangle for profits over from this average total cost, which is different from this minimum average total cost usually. So anyway, be careful about that. That's a real common error for students. Again, it's the vertical distance between marginal cost, that's price, and average total cost, where we are producing, not any other quantity. And then the usual profit rectangle. All right, hope that made sense. And then is this market in long run equilibrium? We'll talk next week. In the long run, remember there's free entry and free exit. So if firms are making a positive profit in this sector, it means they're doing better than they could do in any other sector. It means they're doing better than firms in these other sectors are doing. So over time, the fact that firms are doing better in this industry is going to attract entry. Now entry will occur, and every firm that enters causes the supply to shift to the right a little bit, and as more and more firms enter, the price gets knocked down. How far? All the way down till no more firms are entering. That's the break-even price. That's why it's the long-run equilibrium condition. So if there's positive economic profits being made, that's not an equilibrium. By the way, we could calculate the dollar value of profits. If I don't have my calculator out, that's probably a mistake. Let me do some highlighting here. Well, let's just do it for 490 because that's the easy way to do it from a table. So profits are total revenue minus total cost. Total revenue is 490 times $3.33, and then total costs. Well, we have total costs. Total costs are 1,500. I cheated, paused it, and got my calculator. That is equal to 1631.70 minus 1,500, which is equal to $131.70 profit. Not much, but enough to attract entry. And finally, now I've scribbled over it. Finally, to get to the market supply curve, knowing that there's 1,000 firms in the game, all I did was graph the firm marginal cost and then change the units. Notice that x-axis alone, I didn't label my axes. That should be I redid that graph and didn't do the axes. This should be small q quantity in just bottle openers per day, and this should be price dollars per bottle opener. Duh. Anyway, the important thing though is to go from the firm to the market. I can just change the units to thousands, because if we're summing across 1,000 firms, all identical, each one is producing 490, say just at the market price. That means at the if there's 1,000 firms producing 490 each, we get 460 it was in my calculation of the midpoint. We get 460,000. So that's all there is to it. To get to market supply, we sum across quantity of each firm in the market. It's important to sum across quantity. Students will sometimes sum across price, and that's an error if we're talking about a private good that's rivalrous and excludable. Later on, we'll talk about public goods that are non-rivalrous and non-excludable, and for those goods, summing across the price of the marginal value of each demander to get to the market demand, that's actually the way you want to do it.